Okay, now we have the histogram of the historical demand. Now we're going to use it to generate the simulation for a week. So we're going to start here from this histogram. From the histogram, we know the count of every category. So we can add them up. Add up all the counts, which turn out to be 400 counts. That makes sense because in our data set we have 400 days of demand history. And now we can, for each bin, we can calculate the probability of occurrence of each bin, which is simply dividing the count of that bin by the total count of observations. And then this is our probability for the occurrence of each bin. We're going to use those probability to simulate demand. So now let's move on to this sheet to actually start performing simulation. So I already set things up over here. Let me go through them briefly. First, these are just information given. The current order quantity of the company is 300 flowers per week. The retail price 20. The cost per flower is 12. The shipping cost per week is $500. In the end, we want to perform a simulation to see what is the total profit in a week. Here we will build simulation. We'll simulate the demand for 7 days, and these are the random numbers that we're going to use to generate the simulated demand. And later on, we'll create several columns. In the end, we will calculate the profit. Okay, so the first thing we need to do is generate the simulated demand. But how? Well, from the last class, we learned that we can convert this number into a simulated demand. Well, by looking at this table. So I also post the probability of every bin over here. Okay, this is the same table as here. I just copied it over. I removed the first bin because the occurrence of this bin is 0%, so it's redundant, so I remove it. So we have 11 bins over here. The probability of each bin is here, so we can draw a line here to visualize how simulation is conducted. So here this line is between 0 and 1 or 0 and 100%. The width of every bin is the probability of their occurrence over here. Starting from the first bin. Okay, in the first bin, the probability is 0.25%, so that's a width. The second bin, the probability is 0.75%, so that is the width over here, so on and so forth. With those probability, we can determine the marks for those separating points, which is simply the cumulative probability. For example, this mark is just 0.25%. This mark is 0.25% plus 0.75%, which is 1. This mark is simply the sum of those three numbers. Turns out to be 7.25%. So on and so forth. So you can observe that those marks are simply something called cumulative probability. And each bucket represents a range of demand that we already specify over here. So when we draw a number, let's say 0.26, that's a random number we have. We look up 0.26, that's 26%, which falls into this bin. So we conclude that we generate a simulated demand between 41 to 50. But well, we cannot say, well, in simulation, we cannot just say, well, the demand is 41 to 50. We need to give it a specific number. So we approximate that by just picking up the middle point in this range, which is 45.5. So here, our conclusion is that we simulate a demand that is 45.5. Okay, so that's how it will work. Now we need to tell Excel to do this for us. Okay, how do we do that? Well, we provide this table to Excel over here. We construct a Vlookup table so Excel can understand what we're trying to do. Okay, so here's a very specific form. So for every possible outcome, we need to have in the first column the lower bound of the probability. That's the lower bound of the cumulative probability of each bean. For example, for the first bean, the lower bound, the smallest number in its in this range is 0. So it's just 0 here. For the second bean, the lower bound of the probability in this range is 0.25%, which turned out to be this number. And then for the third bean, the lower bound is this 1%, which is the sum of 0.25% and 0.75%. So we can write it as this: the sum of this number plus this number. And for the next one, you can find that it's simply for the fourth bean, it will be simply this number plus this number. Okay, and you will find that we can use the same formula going forward. You got all of the probability for lower bound. Okay, so this is how we tell Excel to look up this thing. Okay, we provide the lower bound of every bean, and then we need to, in this column, provide, okay, what is a corresponding simulated demand? And as I said, we're going to use the middle point of the range as an approximation. For example, for the first bean, it's demand between 11 and 12, so I'm going to do average. The middle point between 11 and 20, sorry, 20 is 15.5. For the next one, it'll be the range between 21 to 30. So going forward, I can conveniently use this formula, just utilizing the structure over here. It's 21, average between 21 and 30. 21 is 20 plus 1. 30 is a number over here. So I'm trying to use formulas as much as possible to make my life easier. Okay, so here we go. Now we can use the Vlookup here. Vlookup, the value to look up is this random number. The table we're going to look up is this table. I'm going to put the $sign to fix a reference. And the third input is a column index. Enter 2 here because we want Excel to return the second column in this red table. And finally, the last one is true. We want approximation, not exact value. Okay, 45.5, you see? Okay, 45.5. So that's correct. And that's the same for all of the 7 days. So we can just drag it down. But that's not it. The problem is that, well, it doesn't make sense to have 45.5 demand. The demand seems to be, well, we cannot have fractional demand. So we need to round it. So there are many ways to round a number. You can round it up, round it down, or I choose just to use the function called round. A rounded number, here the second input is 0. Second input is the number of decimal place you want to keep. We want integer, which means 0 decimal place. Okay, so it rounds 0.5, so it's a normal rounding, so it rounds up. Okay, good. So we have demand. Well, with the demand, next what? Well, in generating simulation, you just need to think about, so what happened next? What do I need to, what information I need to derive the next thing of my interest? In the end, what we're interested in is the revenue. Okay, so what do we need to determine our revenue? Well, we have demand. We need to know how many we actually sell. So we need sales quantity. Okay, so with sales quantity, we can determine our revenue. Okay, so now let's calculate our sales quantity, which is simply the minimum between the actual demand and the order quantity for the first day. Well, because on the first day we have 300 files available. So it's a minimum of those two because you cannot sell more than what you have or sell more than what the actual demand is. In that case, revenue now is simply the sales quantity times the retail price. Okay, fix a reference to retail price. Good. Okay, so now we move on to second day, and think along the process. Okay, second day, the first thing we know is, okay, we have this demand, and then we can determine our sales quantity, but now the formula for sales quantity is going to be different. Okay, what is a sales quantity? Well, sales quantity will be the smaller of the demand and whatever inventory that is available on day 2. But how do we know what is the inventory that is available on day 2? Well, it's simply the remaining inventory at the end of day 2. The remaining inventory at the end of day 1. So now we realize that we need something called remaining inventory for each day. For the first day, it's simply, well, I start with 300, I sell whatever sales quantity. So I remain with this number of inventory. And they become the available inventory for next day. So the actual sales quantity next day is simply the minimum between the actual demand and the remaining inventory, which is the available inventory for second day. The remaining inventory for second day, well, it's the same formula as, well, it's not the same, sorry. It's simply whatever remain from yesterday minus the actual sales quantity on second day. And finally, I copy the formula here to calculate revenue. Okay. At this point, I realize that the formula for day 2 will be the same for the rest of the five days. So I'm going to drag them down. So usually, the formula for first day will be slightly different. Can be slightly different from the second day because first day is things haven't ramped up yet. Usually, the formula used for second day can be simply carried over to the rest of the simulation. That's usually rule of thumb. Okay, now we can calculate total profit, which is revenue minus cost. So let's add up the revenue, the total revenue out of the 7 days minus cost. There are 2 costs. First, it's a shipping cost. Okay. Second, every week we have a cost for flowers, which is the order quantity times the cost per flower. And now we complete the simulation here.